Okay. So can you see the question now? It says two pendulum have time period T and 5T by 4. They start SHM at the same time from the two extreme positions at T equals to 0. After how much time they will be in same phase, or after what time they would be in same phase, right? So here you could just see that there is two pendulum have the same having different time periods. They starts SHM at at the same time from the two extreme position. Okay. At T equals to 0. So you can just consider that you have two SHM and both has been started from the two different extremes, right? Let's say A has started from the left extreme and B has started from the right extreme, right? But their time period is different, so we can say the angular speed is different, right? So it's not that when A will reach the right end, the B is going to reach at the same point B is going to the left end. It's not same. So there might be a chance that after multiple rotations or even after a single rotation, they are going to meet at a point. They would meet at a certain point and they are going to move in the same direction also. Then only we can say they are in same phase again, right? Right now. So there is two different ways to solve the same question. The first one is you will have to write down the equations for both of them and you will have to ensure that after time t their position and velocity both are going to be same, right? You can just try out that method where you can write down the equation for SHM for the first one, although you can just take the you can take the amplitude different, but it would be easy to take the same amplitude, because in that case you will have to just choose the position in the ratio, in the same ratio. So it's better to take same amplitude. Let's say the expression for the first one is given by x1 is equals to, it is at the left extreme, right? So it can be written as minus a cos omega t. At t equals to 0, the x value is minus a. x2 can be written as plus a cos omega t, right? Now you'll have to find the time when your x1 is equals to x2 and at the same time the v1 is equals to v2, right? This is the first way or first method you can solve this one. What would be the second method? We are just going to use the concepts for UCM. We already know the simple harmonic motion is the projection of uniform circular motion, right? So we can say the two particles are two different at two different extremes, A and B, and you will have to take the sense of rotation same, right? The particle 1 has started from A and the particles 2 has started from the point B. You will have to find out the time when they will meet, or they will start, or they will be in the same phase. They would be in same phase means they will have to meet at the same point, right? They will have to meet at the same point. But because their time period is different, the omega 1 and omega 2 is going to be different, right? What would be the omega 1? What would be the omega 1? it's a 2 pi by t, right now? So 2 pi by t. And what would be the omega 2? This, the angular velocity for the second one. So it seems to be, it should be 5t by 4. So 2 pi divided by 5t by 4. What it is? 2 pi divided by 5t by 4. It seems to be 8 pi by 5. Right? So we can say the second one is moving with a slow speed. Right? A is faster than the B. So definitely they are going to meet with each other. And what is the angle difference between them? This is the phasor for B and this one is phasor for A. The angle difference is pi. Correct? So here we can use the concepts of relative velocity also. Fine, na? We can say we need to find the time when A catches B, because A has a more speed. The omega 1 is greater than omega 2. So A is going to catch B. So basically you need to find the time when A will catch the B. Fine? So first of all, you will have to find out the relative angular velocity. Relative angular velocity of A relative to B, which is omega 1 minus omega 2. And what is omega 1 minus omega 2? 2 pi by t minus 8 pi by, it's a 5t, sorry, 5t. So your answer would be LCM is 5t. 5 minus 8 is 10 minus 8 is 2. So it's a 2 pi by 5t. This is the relative velocity, 2 pi by 5t. And how much angle it has to be traveled? The gap between them, the angular distance between them is pi. So you can find the time, by what time the gap, the gap between them, which is pi, will be filled up or will reduce to 0. So the angular position is pi and the angular speed by which this pi is going to reduce is 2 pi by 5t. So let's 5t this side. Pi would get cancelled, right? So it's a finally 5t by 2, right now? It's a 5t by 2. It's option third. Is it clear, students? Any doubt?